They were talking about graphing, creating graphs, analyzing graphs, and tables as well. So a line graph is it's data that's represented by points, which are then connected with a line, perhaps, if it makes sense within the context of the problem. Bar graphs are vertical or horizontal bars used to represent different pieces of data. So, like, how would you know if you should connect the lines or not, or connect the points or not with a line? So if you had a graph that shows the number of CDs purchased versus the cost, you would not connect them because you can't purchase a half of CD. Because when you connect a continuous line, it means everything between those integers. Now, if you had a graph that showed time versus number of miles biked, that would make sense because I can bike a 1/100th of a mile. Maybe I just plotted my miles and the time that it took to get there. But in between those 2 points, I'm biking some miles. Now, perhaps I took a break and whatnot. We can get into the details of slopes and whatnot later, but it would make sense that as long as time's going and I'm moving, I can break that mileage down even further. Whenever one of the variables is time, that should go on the x-axis. When you make a graph, make sure that you have a title addressing what the graph is going to be showing. Make sure you label the x-axis, which is the horizontal axis. What are those values on the bottom? What do they represent? Hours, minutes, seconds, class periods. Label your y-axis as well. That's the vertical axis. Make sure your scaling is going with even increments. So if on your x-axis you choose to go from 0 to 2, then you need to make every increment on that x-axis worth 2, or an increase of 2. Now, whatever your increments on the x-axis are, that doesn't have to be the same for your y-axis. If you're going up by 2s on the x-axis, you go up by 5 or 10 or 15 on the y-axis, but whatever you choose to go up on the y-axis, say it's 10, you need to go up for every increment on that y-axis. And then make a key if needed. If there's more information that needs to be shown, make sure you do that. So here I'll actually show you where a key could be used. So here I have some years. Well, I should read the directions. It says consider the following data showing enrollment of 2 high schools in Omega, Wisconsin over a period of 5 years. So these are 2 high schools. These are the populations. So say I choose to plot Alpha High School here. By the way, before I do my scaling, I guess on the x-axis here I would put 2010. It's going to be a bit of a break in the action. We don't know when this high school started, but we're starting in 2010, 2011, 2012, 2013, 2014. I suppose I could have spread that out more. So we're making a bar graph. Now let's look at our scaling here for population or enrollment in the high school. It looks like our lowest is 765 and our highest is 1,122. So maybe I think I could put 700, well, let's do 0. We'll put a little break in the action. 700, 800, 900, 1,000, 1,100, 1,200. This is high school enrollment. So now I'm labeling my y-axis. I'll label my x-axis, and I'll title this Omega High School. Omega High School's enrollments. And then what about a key? In this case, I'll start graphing it here. So alpha is at 934. So I wouldn't go quite halfway up between 900 and 1,000. Now here's the deal, folks. When I do beta, how do I do that? I mean, do I just make another bar at 765? How do people know which one's which? You know? So maybe we make a quick key over here. I'm going to say that a open bar like that, with no shading or anything like that, no coloring, is alpha high school. And on this one right here, I'm going to put some pretty lines. I'm going to say that's beta high school. So now I can proceed on. Notice it doesn't mean it, you could use colors. You could also distinguish it that way. But if you're just using your pencil right now, you can get away with just using the shading scheme right here. So 873. Whoa, 873. So beyond halfway. That's about as picky as we need to get. Is it below or above the halfway point? Whereas beta is 831, so that's going to be below 850. Whoa, I was looking at something else. 2012, we go 1,122, so a bit above 1,100. And then 902, a bit, just a hair above 900. You really can't even show that very well. 1,083, so close to 1,100, but not quite. Notice my lines are not perfectly straight, and that's okay, folks. Try to make them as straight as you can, but don't get in a tizzy over that. That was beta, so I'm shading it. So on and so forth. Now in a second, we're going to analyze what's happening here. There we go. Alrighty. So there's some questions here. In what year did Omega see a population surge based on high school enrollments? So, and this is actually a bad question, because just because your high school has a few more kids doesn't mean the population's actually surging. It's normal for populations that are consistent to have some years with more students in a certain grade and less students in another grade. So I guess, we're looking for where is there a surge in enrollments. So let's say, in what year did Omega see a surge of enrollments? That was a little bit picky, but so I like to look at our graph. You could use the table and try to identify that as well, but the beautiful part about a graph is it really kind of accentuates it here. So, I mean, with alpha, there's a massive surge right here. Boom. And beta also surges a bit too. Whereas here we're going down, down, down into the burning ring of fire. So that's, I guess it's the 2012 school year, I guess we'd call it. There was a surge in high school population in 2012. Notice how I made a complete sentence. I even put a period at the end. Yeah. Describe what is happening over these 5 years to the enrollments at the two schools. So there's no only one right answer typically. Just look for some truth. Well, it looks like beta increased pretty much. It went increase, 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 and it decreased a little bit. And that's hard to see with my bar graph because the increments are so high, but they're so close together that it's really hard to tell the difference. But basically, it's increasing over those 5 years. And then if you look at alpha, it decreased and then had a huge increase and then decreased a little bit more. But overall, there was an increase over the 5 years in the enrollment. So we could really summarize it and say that overall, alpha over all alpha and beta increased enrollment over the 5 years. You could get more specific and highlight the big years that had, or the years that had the biggest gains, or when things were increasing and decreasing. Which school has more consistent enrollment numbers? So if you look at the trend, and here you can kind of make a line to show the trends. The one that has the most consistent, the least amount of variation is definitely going to be beta. If you look at the red line, it's moving up. Yes, it does change, but not as much as this one's all over. Alpha's all over the place. Beta has more consistent numbers, enrollment numbers. We're skipping this part for next time. Yeah, we'll do that. That'll be all right. All right, and